All right, I think we can get started. So yeah, as I was saying, this is on the Facebook, this slide, if you want to check it out. Just basic information, just so that we don't have to give you a lecture before we start. We can jump right into the discussion. Got a good turnout today, over 70 people, which is great. Great to see there's a lot of interest. And I assume most of those people are Monash students, which is great to see. I love seeing some student engagement with energy. It's the whole point of the club, and I think we've been doing a decent job with these webinars. So I'll jump straight into it. Thank you very much, all of you, for coming. This is part 2 of our 4-part webinar series called Grounded. My name is Alex. I'm the chair of the Monash Energy Club, and I will be moderating and hosting today's webinar. This webinar is on the future of electric vehicles in Australia through the lens of 3 Australian vehicle experts that I'll introduce shortly. The entire Grounded webinar series is trying to look at the future of energy in Australia, what are the drivers behind it, how it's going to change, and also a chance for you guys, for the audience, to meet some of the leading industry experts in Australia, and learn a little bit more about the industry that you might be joining and be employed by in the next few years or next decade. So I'll get into introducing our panelists. First is Tim Washington. Tim is the CEO of JetCharge, which supplies electric vehicle charging infrastructure and services to a broad range of customers, including governments, councils, residents, and businesses. Tim is also the co-founder and director of ChargeFox, which owns and manages Australia's largest charging infrastructure network, as well as being chair of the Electric Vehicle Council of Australia. So probably one of the most successful EV entrepreneurs, I think, in Australia, maybe. No, he's shaking his head. Next, you have Kristian Handberg. Kristian is the electric vehicle lead at AGL Energy, which is one of Australia's largest Australian utility companies, and provides around 20% of all electricity on the national electricity market. Kristian develops electric vehicle strategy, business models, and has a more broad focus on decentralisation at AGL. AGL has been publicly supportive of Australian electric vehicles with their recent electric vehicle plan that actually provides a discount to customers on the electricity bills if you own an electric vehicle. Kristian also did his Bachelor of Engineering here at Monash. Not sure when. Was it in the 90s or in the in the noughties? There you go.
Yeah, long time ago. Yep.
Quite a long time ago. All right, and lastly is Scott Nargar. So Scott has been at Hyundai for almost 10 years, working his way up to Senior Manager of Future Mobility and Government Relations. Scott has played a huge role in establishing hydrogen vehicles into Australia by commissioning the first Australian first hydrogen refueling station, and imported the world's first hydrogen SUV to Australia, as well, whose leadership has led to Hyundai being the only automotive brand in Australia to have all 4 types of eco vehicles on the marketplace. Scott is also the co-founder and director of the Australian Hydrogen Council, which hopefully has their Australian Hydrogen Conference sometime this year. Fingers crossed. Now, in terms of audience participation, we are looking for your questions, and we are hoping to answer as many of your questions as possible. So there is the Q&A function. So please use this to ask any and all questions. You can ask them anonymously if you don't want to, I don't know, if you don't want to be unmuted. But yeah, use the Q&A function, not the chat, because we won't be looking at the chat too much. So you can vote and comment on your favorites for us to ask. You will be given permission to unmute yourself and to ask the panelists the question yourself. But if you'd rather be muted, then just let that be known in the question. All right, well, we'll jump straight into it. I think we should first start off with just by setting the scene of hydrogen fuel cell vehicles versus battery electric vehicles. We do have representatives from both sides of the argument here. So if I could just start with maybe Kristian, where can we expect to see hydrogen vehicles and battery electric vehicles in the next 10 years, and what will their sort of uptake look like, and how will they compete against each other or is there the potential for both of them to exist at the same time in the same market?
Yeah, good, fair question. So I just want to preface this by saying that you might get quite a, let's say, an ideologically driven debate in this space, people who are either advocates for one or the other. And I'm firmly of the pragmatic point of view that is you get the right tool for the job. The economics at the moment suggest that hydrogen is going to be well suited to potentially larger vehicle applications, heavy trucks and the like. And so right now, obviously, we've got an abundant resource. We stand as one of the markets in the world where hydrogen might well be cheap by comparison with other markets, but it's still on the front end of the cost curve. So electric vehicles have got a head start. They look better suited to light vehicle applications now and in the future. And in terms of the technology availability, we'd expect to see some of the large vehicle tech come through, but Scott certainly has got some interesting projects in this space, so I'd defer to him on that one. You're on mute.
Yeah, from a Hyundai point of view, we're not picking a winner. Globally, we're introducing hydrogen fuel cell vehicles and also battery electric vehicles. In Australia now, we've got plug-in hybrid vehicles, hybrid, battery electric. We've also got the first 20 of our hydrogen fuel cell vehicles actually here in Canberra. I've just arrived at a hotel quickly to get into this conference, and I've got a hydrogen fuel cell vehicle with me right now, which I'll be doing some stuff with some ministers later on today. So governments around the world are driving the transition. The ban of internal combustion engines will start in some European countries from 2025 onwards. As a manufacturer that sells vehicles into every country in the world, we've got to have vehicles that meet those requirements. And for us, it's having a bit of everything. So we're playing in all fields, both heavy and light vehicles. We also build trains. We're the biggest shipbuilder in the world. We're right into drones. We're partnering up with Uber for air taxis. So there's nothing Hyundai's not doing. So it's a pretty exciting place to be at the moment.
You're on mute, mate.
Thanks. Hyundai is headquartered in Korea, and Korea seems to really be locking down into a hydrogen economy. I think they've got plans for something like 800,000 units by 2030 of hydrogen fuel cell vehicles. So how does that sort of tie into what's going on in Australia, where you're sort of playing both sides of the market?
Yeah, it's a little bit difficult here. 1.3% of what we make globally is right-hand drive. So anything that we bring to Australia, we need to justify it in volumes. It's hard to justify even hybrid vehicles or plug-in hybrids in volumes in this market, let alone EVs and fuel cell. But we've got cars certified. So we've got the first hydrogen fuel cell vehicle certified for this market. They're going to hit the roads. I'll be driving one this afternoon. I've been driving that for a year now. They've been crash tested 5-star. And also EVs are going very well. The ACT government, and where I am today down in ACT, they've got a strategy where all of their vehicles, where applicable, will be zero emission by 2021. Now, they're a fair bit off that at the moment, but they are making big inroads into having that transition happen. So we're going to have the vehicles in the market to meet those requirements. We've got 2 EVs in the market now, the Ioniq and the Kona, and we've got more coming starting next year with another EV, which I won't talk about.
Alex, can I just add something as well? I think it'd be a mistake to think that anybody's locked into anything at this point. I think I read somewhere that people can make predictions about 5 years out, and anybody who can tell you what will happen 5 years out are just bullshitting because things just move too fast. You said that Korea's locked themselves into a hydrogen economy because they've committed to 800,000 hydrogen units by 2030, but Korea has 21 million cars on the road. So, it's a tiny percentage compared to what's happening overall. Scott, Kristian, and myself may all be out of a job in 5 years because some other thing will come about. I don't think that's true, but I certainly think that the split between hydrogen and battery electric simply has not been determined right now. You've got extremely smart people, for example, in the US, Tesla banking on battery electric trucks, whereas Nikola are banking on hydrogen. Who's to say who's right now until the technology is proven? I think for us as a country, more importantly, it's important to view the transport debate as not being divorced from the energy debate. I mean, you're the Monash Energy Club. Any transition that we have towards a hydrogen or a battery electric market will have direct implications of how we view the energy market as well. And I think it needs to be viewed in that context of where we want to go. And I think it'll also probably inform some of the lobbying and education that's happening in the political debate right now around hydrogen versus battery. I think there are kind of more at play than just the transport side. I think the energy side will play a vital part of where it ends up.
Right. So do you think you could see hydrogen as being, I guess, useful for things like storage and those sorts of things, whereas battery is more centered towards transport?
Of course, yeah. I think, of course you can use hydrogen for storage. That's definitely on the cards, and certainly the Australian government believes in a strong hydrogen future. At the same time, Mike Cannon-Brookes thinks we should build a huge DC cable from Australia to Southeast Asia. Who's to know, like, who's better? I think it's just a mixture of things. So I think it's important to keep an open mind is, I guess, my point more than anything else.
Right. Could we see JetCharge going down or ChargeFox moving towards some sort of hydrogen infrastructure then?
No.
No. All right. Well, Kristian did mention heavy vehicles, and that's something that I'm quite interested in, and I think sometimes gets overlooked in terms of the whole EV debate, at least from a public point of view. One of the problems that I found with, or I've come across with heavy vehicles is the long turnover rate of a fleet. You might have a car which turns over every 10 years or something, but then with heavy trucks, it's closer to 20 or 30 years. How are we going to how are we going to replace these heavy diesel vehicles with things like hydrogen or things like battery electric vehicles? I might throw that to Kristian, seeing as you're the one that brought it up.
Yeah, I think slowly is probably the obvious answer. Like you said, the vehicle economics unfold over a quite long time in terms of the business case. The vehicles go through a couple of sets of owners as well. So what will happen is that you'll see captive fleets who want to take a systems approach to realising the whole of life operating cost benefits from the new vehicle and the infrastructure coordinated rollout. They'll deploy first. And that's something that we've seen in the past. It happens in trials, and then it can happen on a larger scale. And so you might see it in, for instance, I'm not saying it's a mining application, but you could see it in a captive fleet that was in an industry segment, for instance. So, but yeah, certainly heavy vehicles in Australia. There are projects blowing around that I'm not involved in, but I would expect that you'll build out from those project models. More widespread with, let's say, openly accessible refueling infrastructure that supports just free driving the vehicles anywhere. That's a much tougher mountain to climb, and very expensive infrastructure investment. And as Tim said, people taking that risk right now, in an investment perspective, that's a very hard road. So it will go along a pretty predictable path of project models and trials before it gets to that point. So is heavy vehicles then going to be one of the major challenges for sort of decarbonisation, or do you think something will kick and it'll turn over more quickly? To my way of thinking, yes, it is one of the harder challenges. There's aviation, there's sectors that are quite hard to decarbonise, and that's why a lot of the technology remain in trial status at the moment. We're still trying to figure out what the right solution is.
Is retrofitting?
Sorry, Alex, I was just going to add that I think with heavy vehicles, it's really forced companies to look at to segment their operations even more. And so, whereas previously it was pretty much only about form factor when it came to like last mile deliveries versus interstate haulage, now people have had to do more analysis on exactly what type of vehicle they need, because battery electric may be very suitable for kind of intrastate or last mile deliveries. And in fact, there's some very exciting companies coming up around the world. One recently that I read about and I looked at was Arrival in the UK, which is some amazing last mile delivery vehicles that's happening over there. But I think on the long routes, that's where you're going to face the biggest challenges with battery electric. And this is where I think the hydrogen fuel cell technology is probably going to be more suitable in my head, because I was speaking with a logistics company, and they said to me, Tim, we literally don't turn the engines off. They said, we don't turn the engines off. Because if we turn the engines off, that's basically time we're not making any money. Yeah. And so EV charging, regardless of how fast it is, requires you to turn the engine off every now and then, because we fuel overnight a lot of the time. if you had to deliver into, you know, a 1 megawatt hour battery pack, all of that charge within, say, 10 minutes, 15 minutes, I mean, the amount of, I can't even really fathom that at the moment. That may change, but I also think there is definitely a role for a mixed kind of fuel use for heavy vehicles. It will just be segmented more.
Right, interesting. Now to Scott, I did see Hyundai had a presentation at the CES 2020 of their future of mobility in 2030, and that did include those air taxis with Uber that you were talking about. It was probably the most optimistic vision I've seen in the electric vehicle market, with autonomous driving and autonomous shuttles everywhere. Are we too far away to think about those sorts of electric vehicle shuttles, or would you agree with the vision that Hyundai had for 2030, or is it a little bit too optimistic?
No, it's the money that Hyundai's invested into this program is huge. They've got whole teams and divisions in Korea working on it. So remembering we build everything from cars to ships to trains, tanks, everything else in between. So this is just one facet of it. And there's a number of cities will be trials as part of that around the world. And the announcement with Hyundai and Uber together, it was a great coup for our brand, where we could team up with a very well-respected brand that's already out there delivering similar services, but we come in with the hardware to be able to make that happen. So there's a very big team happening. I can't go too deep into it, but there's a whole R&D division and divisions of people working on this project. So the money's been invested massively in the right way, and it will happen. Everything Hyundai said that we want to do is they've made happen so far. So just sit back and watch it roll out. And Melbourne is that test city. So.
Oh, really? Oh, interesting. All right. Well, I'd like to get a question from the audience. So I'll hand over to Linus to dig through the Q&A. Linus, if you're there. You have to unmute yourself.
Yep, I'm here. Yep. I've got a question from Faisal, I think it's pronounced. I'll unmute. Yep, I'll unmute and let you ask the question.
Thanks, Linus.
All right, you should be good to talk now.
Yeah, can you hear me?
Yep.
Yeah, so my question is basically more on the hydrogen topic. So a lot of times when we look at the hydrogen cars, we look at hydrogen as a fuel. But hydrogen cars use fuel cells that need platinum, right? And platinum being very scarce and expensive, what kind of challenges do you think that we're going to face regarding this? And would we be having enough platinum to supply like millions and millions of cars? Because if you're looking at hydrogen as the way to go, we would be expecting to replace majority of the cars that are there on road by either electric or hydrogen. And if that is the case, will we have enough platinum to supply the fuel cells of the cars?
Thanks, Sal.
Yeah, that's a really good question, and it's something that I've asked in Korea itself. We're working very hard to use non-precious metals in fuel cell stacks, but we do use platinum in the current stacks in the membrane. We use just slightly more than the platinum that we use in a catalytic converter for, say, a Toyota Hilux or a Land Cruiser size vehicle. And remembering, we're not using those other precious metals either. A catalytic converter uses platinum, palladium, and rhodium. We're only using platinum, and we're using just slightly more that's what's in a catalytic converter of a regular vehicle now. But the idea is to get down to the point where we're not using precious metals. We're not relying on those really sensitive markers to get the products we need to market. But I know that there's universities here in Australia that are actually working on fuel cells that don't have any platinum in them. They're not getting the same range and durability as we need right now, but it's not to say that won't happen or change very quickly.
Great, thanks, Scott. All right, well, then we'll move on to cost competitiveness. Most of the people here are students, and I think all would love to get an electric vehicle, but with no second-hand market really at the moment, and electric vehicles in the $50,000 plus range. When can we sort of start to see these vehicles become cost competitive with internal combustion engines? I might chuck that to Tim. Yeah.
So from a battery electric vehicle perspective, current estimates are around 2025. We will see cost basically what we call dealer level price parity. So that's essentially when you walk into a dealer or when you look online or whatever, it's going to be the upfront price is going to be similar. That's probably going to happen in Europe first and in other countries with strong mandates around electric vehicles. Doesn't take into account subsidies or anything like that. It basically just takes into account the amount of volume of vehicles that'll be able to enter those markets. In Australia, we expect it to happen a bit later because we're a small market. We tend to have less buying power as well. So probably a little bit later. At a total cost of ownership level, so what I mean by that is if you have your car for 5 years, 10 years, if you look at the maintenance and fuel savings, many fleets within Australia already are seeing price parity between electric and petrol vehicles. They predominantly reside in the luxury chauffeur space. I know that seems ridiculous for a bunch of students that there are whole companies designed around luxury chauffeuring, but there are. So they're seeing price parity there already. But I think the whole thing about price parity is that it almost doesn't matter whether it's 5 years or 7 years or 10 years. It doesn't matter because the trend is only going in one direction. And so therefore, if you know the end point is going to be price parity, in fact, you know the end point is that battery electric vehicles will be cheaper than internal combustion engines, then what are we going to do as a society, as a community, to basically get our industries up to speed with that endpoint? The fact that it happens in 2025, 2027, it doesn't really matter. For a vehicle OEM, from basically concept design stage, like when it first hits the drawing board to full product maturity, maybe second model on market is 7 years. So the models that are going to have price parity at this point have already been pretty much designed. And I think it's more important to look at the impact of price parity. So if you have a look at somewhere like Norway, that because of government subsidies and taxes have already reached price parity or lower for battery electric vehicles, what you see is about 50 to 60% market penetration for electric vehicles. And what that means is that people want EVs. It's just the price holding them back.
Right. So is it sort of the role of the government there? Like, is one of the reasons why EV uptake in Australia is so low is it due to a lack of government subsidies and government incentives, government policy altogether?
I'll
let Scott talk to that. He's full-time on this, aren't you, Scott?
Yeah, it is. I've got to be very careful because I get in trouble for pushing governments. But it is. It's something we need to work with the government for, and we recognise the work that's been done by the Cleangy Finance Corporation and also ARENA in helping fund projects that Tim's involved in and other EV and fuel cell companies are involved in. But getting cost parity down is something that we're working very hard on. It's all driven by volumes. We build 5.3 million cars a year in the Hyundai Motor Group. There's only a very small percentage of those are hydrogen fuel cell and electric vehicles now. When you're buying in a component, whether it be a small component of a vehicle, or I remember having some journalists in Korea recently when we could travel, and they asked a question about cost parity, and I was saying that if we buy units for fuel cell vehicles, it was a small three-way valve for a cooling system, actually similar to what we've got on the electric car. If we buy them in units of 500 or 1,000 at a time, or 10,000 at a time, we'd be paying $435 per unit. We buy those in at 300,000 units at a time. It's $35 a unit. It's all about getting the volumes up so we can buy more of the same parts in. And we're trying to do that ourselves. So if we look at our hydrogen fuel cell vehicle and our Kona electric, the electric motor in our Kona electric is exactly the same as the motor in our hydrogen fuel cell vehicle. The battery in the hydrogen fuel cell vehicle is exactly the same as the battery in our ionic hybrid. The control mechanisms and control systems for the high voltage EV side of it and the fuel cell vehicle are the same as our Kona EV. So it's making sure that we use as many components across as much technology and platforms as possible. An example, the battery is a 64 kilowatt hour battery in Kona EV. In our electric buses, we have 6 of those. Exactly the same part number, exactly the same part. It's a water-cooled battery or liquid-cooled battery. We have 6 in a bus. We have 1 in our electric car. So for our perspective, from a manufacturing and R&D perspective, there are teams and teams of people, and I've taken Tim to Korea previously, and he's got to walk through our factories and have a look at our R&D centres. The biggest R&D centre of any manufacturer in the world is with Hyundai, and 30 kilometres away is the second biggest R&D centre of any manufacturer, and it's still owned by Hyundai or the Hyundai Kia Group. So we're putting a lot of money into that. We've been lucky enough that we're starting to share a lot of our technology now with other manufacturers. So, example, we've got an agreement with Audi, Volkswagen, Skoda and Porsche to share our technology for fuel cells. And we've also got an agreement with Cummins for our fuel cells for heavy vehicles. And you think of what Cummins large diesels power from, excavation equipment, trains, trams, buses, ferries, trucks. It's just endless. So it's all those years of R&D starting to pay off now, where we do share and or sell a lot of our components to other manufacturers, which is great. And that helps with R&D, helps get the cost down and helps get things down to parity.
All right, thanks, Scott. Before we move away from government, there is a question from Wendy Cox about diesel subsidies. So if Linus, you could let Wendy speak, that'd be good. Thank you.
Yep, you should be good, Wendy.
Yeah, I believe I read a paper about what the EU's doing in terms of building their hydrogen infrastructure, for example, and what they're doing is putting an excise, from what I believe I read, on their fuels. I'm just wondering a couple of things. One is potentially doing that here, especially given that the prices of things are so low at the moment anyway. But also the other side of the coin is emission standard policies. If we had that on existing cars, that might also be a disincentive, which would encourage people to move on to a different car, hopefully.
Yeah, and that also encourages manufacturers. We're actually the opposite here in Australia. We actually have subsidies for diesel, so we don't tax it for a lot of the primary producers and tourism operators and different people like that. We actually give them quite attractive subsidies to keep using it. We don't have emission regulations in Australia. If you look at the OECD, there's only 2 countries that don't have it. It's ourselves and Russia, so we've got some good partners there. But the automotive industry has announced some voluntary emission regulations that will start to roll out from next year. And it's a target between now and 2030, which will hopefully encourage manufacturers to bring vehicles in that are below the curve. So from our perspective, it won't change what we're doing. We already had planned to bring a lot of EVs into the country and hydrogen fuel cell vehicles, and we're working on programs for heavy hydrogen fuel cell vehicles and marine applications, and stationary fuel cells for backup power generation and powering sites. So we'll just keep plugging away with what we're doing. But emission regulations around the world have driven the transition. We just don't have them here yet.
What do you think is likely to happen first, an emissions regulation law or a commitment to a ban on ICE vehicles in Australia?
It'll be emission regulations. It'll be emission regulations first, but we've expected over the last couple of years, and it hasn't happened, and that's why the industry's moved forward now to introduce a voluntary one, which is great. It's a start. We did get kicked for it, saying it wasn't hard enough and big enough, but again, it's the industry trying to take a lead because we haven't got a lead from our regulators yet. So it's great what we're doing. It's something we hope will be picked up by the governments. And again, from a Hyundai perspective, the cars are coming in a way that we're doing what we'd be doing whether if there's emission regulations. Our business at the moment is to plan as if it's already in and keep working towards meeting a really good figure in the future. Mm-hmm. And if you're a manufacturer not doing that right now, you're probably not going to be in business in the future.
All right, thank you. Now I'd like to move on to charging infrastructure and its relationship to the national grid. I think this is one of the controversies around EVs and potentially one of the myths, says the Electric Vehicle Council's website. What is the relationship going to be between this increased demand from electric vehicles and the national electricity market? I'll hand it over to Tim, and then I'd like to hear from Kristian.
I think at a very basic level, the best way to understand it is that having more electric vehicles on the road means an increased demand on the national electricity market. The question is, how do you manage that demand? And so one of the myths is that our grid is going to break. And that's simply not going to be the case. It's just a question of how efficiently can you allocate the electrons on where they need to be. And so if you think about a situation where we hit, say, 60, 70% EV penetration, if all of those EVs plugged in at exactly the same time at 5 p.m. at night across the country, yes, the grid will be in trouble. The same would be true if everybody turned on their air conditioners at exactly the same time across the grid. So the grid faces these challenges, and the grid is built for maximum demand, essentially. So, you know, I'm sure you cover these kind of concepts in your club, but you build for essentially what the maximum amount of usage is, but most of the time you don't use anywhere near that amount. And the only question for us is, how do we make sure that electric vehicle charging is managed in the same way? And as long as it is managed, not only can it basically not harm the grid, it can also be a benefit for the grid, both from a efficiency perspective and also from the use of renewables. So yes, it is a myth, but we do need to manage the charging.
Is this something that AGL is thinking about intensely, Kristian?
Intensely, yes. Thanks for that, Dorothy Dixon. We very much view electric vehicles as distributed energy resource, battery on wheels, and with that it does actually bring opportunities. So beyond managing the EV grid integration problem, which will be felt by the distribution networks, particularly at the residential area, the opportunity is to use this relatively large flexible load to be able to try and solve other energy system problems. And so it fits within what we describe as our virtual power plant architectures, and you'll hear other retailers talking about that also, because the future for energy retailers moves away from simply coming up with the bill and selling electrons effectively through the normal NEM reconciliation to actually energy management services, and that will support the decarbonisation of the system. So we're working quite hard on that. We've got a fairly advanced virtual power plant architecture and portfolio, and we can already handle large numbers of residential batteries. And we actually believe that electric vehicles as a resource in the system will far outweigh even residential batteries in significance for helping solve wider grid problems. So yeah, very, very big topic within AGL, and potentially one of the major reasons for us being excited about electric vehicles.
Are we able to see electric vehicles at some stage sort of decentralize the entire energy grid? Like, I think could it reach the point where we're all driving around our own little power plants with solar and batteries in our houses? Is this a actual possibility, or is it sort of a bit of a pipe dream?
No, that's available right now. I mean, it's an early adopter proposition right now, as in it's relatively expensive. There's a quite high risk of technology obsolescence around some of those things. And to be honest, it's quite challenging to try and get everything work in a harmonious way. This is pretty normal. If anyone's mucked around with smart home type devices, they'll know that sort of experience, trying to get stuff to talk to each other. But realistically, the electric car, Tim and ourselves are involved in projects which is around vehicle as storage applications and technology. And while they're still quite early stage, for certain use cases it really stands out, and that there will be customers who it potentially makes more use for them to be able to use an electric vehicle as storage than it would for them to deploy a residential battery. So part of what we're working on at the moment is to try and understand what those scenarios look like, what's the potential value, who the customers might be, and this is with a view to potentially the next 5 to 10 years that becoming a relatively, let's say, mainstream offering. So it won't be for everyone, but it will work for some people really well in certain circumstances. So yeah, it's an exciting time.
Are we saying, to Scott, are we saying most of these electric vehicles having the capacity, I think it's called reverse charging, of being able to take electricity from the battery and use it in your household?
Yeah, so it's something that Nixon is doing right now with the project here in the ACT, and they've got 51 cars getting deployed. We're not part of that project. We don't have bi-directional charging yet. It's only available with the Chatamo plug currently, but we are working towards, I'll be talking to both my colleagues to them about opportunities in the future with getting this happening. But it's a great opportunity for all manufacturers. We chose to go with Type 2 CCS charging, and that just meant at this time we don't have that technology available, but it is getting to the point where it's going to become commercial in the near future.
All right, thank you. We'll take another question from the audience. So I'll hand it over to Linus once more, and we'll see what we've got. Linus.
Yeah. We have a more technical question from Bryce. So I'll unmute you, Bryce. Yeah, you should be good now.
Bryce Gatton.
Yep.
Hello,
Bryce?
can you hear me?
Yep. Yep.
Right, I had to quickly connect my headphones and microphone. Yes, it's a quick question to Tim, because I know you're talking about releasing some vehicle to grid or vehicle to home systems later this year. I was wondering what your take is on Nissan dropping CHAdeMO outside of Japan and going to CCS versus what's happening with the CCS timeline. They're talking about 5 years before you can do V2X type stuff.
Yeah. So everyone, Bryce is not a Monash engineering student. I know that for a fact. Good to see you on here, Bryce. So there's a few things. The first is that you're right. Nissan is dropping CHAdeMO in many places. That's not because they don't believe in CHAdeMO, but it's because of some wider political implications of the infrastructure that's being rolled out across Europe and the US. So as a very quick kind of background to everybody, there's essentially like, plug wars kind of happening that nobody cares about apart from the automotives. And they basically have built really large networks across Europe and the US, various manufacturers that are CCS2 only. That has necessitated essentially CCS2 being the standard. They don't have CHAdeMO plugs on them. So if you've got a Nissan vehicle in Europe or the US and it's got a CHAdeMO plug, then you can't use a lot of the charging infrastructure around. And so obviously then Nissan have made the decision to go to CCS2. Now, one of the effects of this is that the bidirectional charging standard for CCS2 is a little bit behind CHAdeMO. Having said that though, Bryce, the latest on that from Charing, which is the kind of group that regulates CCS2 as a plug standard, they are no longer looking at 2025 as the year in which they release bidirectional charging. In fact, I was on a recent call with them and they said, as a point of clarification, 2025 was not the first release, but rather maturity in the market. So what they viewed as maturity in the market, they think the first release will be 2022 to 2023. So they are looking to release the draft standard on bidirectional charging, hopefully by start of next year, if not earlier. And then companies will start working towards that draft standard. So it's going to happen on all vehicles much sooner than we thought it was. Even I thought it was. So there's, in the grand scheme of things, a couple of years, not going to make a difference.
Thanks, Bryce.
From our perspective, we know exactly which vehicle is coming on and which year, and almost we can't give a month of production, but which quarter of that year. So we know exactly when it'll be available, and it may be in the middle of a vehicle's life cycle. It might be a facelift or it might be a new vehicle, but I can't say, but we know exactly when that's going to happen for ourselves.
Okay, so are we seeing a huge change in terms of innovation in this area? Is it something that's changing month by month? No,
I think most manufacturers have got the technology. Yeah, sorry. Most manufacturers have got the technology that want it, and it's just a matter of getting it ready for commercial applications.
All right. And in terms of charging infrastructure, Tim, what sort of challenges are we seeing there? Is it a simple rollout, or are you getting pushback from governments or private retailers?
Yeah, so this gets a little bit technical. So bidirectional charging can happen either as basically like a DC function or as an AC function. So what I mean by that is the bidirectional kind of inverter can sit either on your wall in your home, or it can sit inside the vehicle, in which case a simple, like any AC charging station will do to effect that power transfer. And so where everyone's getting a little bit nervous is if the vehicle manufacturers decide to incorporate bidirectional inverters inside the vehicle, because then any AC charging station essentially becomes a little power plant, which is an absolute nightmare for regulators, distribution network service providers, all of that. So in the US, where this is kind of been mooted, especially by bus manufacturers and basically like more customized vehicles, the conversation that's happening within California at the moment is that they may actually just ban kind of AC bidirectional charging, so where the inverter sits inside the vehicle, because they can't control it, because they don't know where these things are going to rock up. At least if the bidirectional charging happens on the wall, you can register that like any other inverter. It can be part of a, DER database, and like people can control it. If it's just anywhere you plug in, then it's going to be very difficult. I don't know what the future is going to hold for that, but certainly from an infrastructure rollout perspective, it's easy. So as the hardware manufacturers kind of release bidirectional chargers, they get certification with the vehicle manufacturers themselves, it'll act like any other charging station. And so the scary thing, I think, really for a lot of companies playing this space is just how easy it's going to be to install a charging station that will give you enough power through your vehicle to power the house for a couple of days. And so, and the fact that it's going to come with every electric vehicle, whether you use it or not, is also as kind of, not as, it's an exciting proposition, but also for kind of incumbents in this area, it's also quite scary. So yeah, but the future is bright for it. It's pretty easy.
And are we seeing most of those charging stations to be, I know ChargeFox has a variety of speeds at which they can charge, including one that does 15 minutes in 400 kilometers in 15 minutes. Are we more likely to see charging stations pop up that are those super fast chargers, or are they more likely to be those 60 kilowatt or? Are
you talking specifically about bidirectional, or are you kind of?
No, not. I'm talking more about sort of highways and irregular stop-off recharge spots.
Yeah, okay. So so just kind of, I guess, changing to charging infrastructure as a whole. The thing to keep in mind about charging infrastructure is that it's not supposed to mimic our existing fueling system. Right. The existing fueling system will act only as one point of comparison for charging infrastructure. But the great thing about EVs is that you get to charge them anywhere there's electricity. And so, yes, we will be rolling out high power charging stations on highways, but most people don't actually go to the freeway kind of petrol stations very often. Most people spend most of their time at home or at work or, wherever. And so those are where the vast majority of charging will happen. And so I would say that 75% or 80% of EV charging infrastructure that's being rolled out right now, you won't see visually on a day-to-day basis, because it's in people's garages, it's in basements, it's wherever. The public charging infrastructure is the stuff that gets the attention, but the private charging infrastructure is where most of the action will happen.
Now, looking outside my window, most of the cars are on the street. How do you fix that problem of setting up charging infrastructure when people leave their car on the street overnight?
It'll be a combination of basically smarter on-street charging, like through light poles and power poles, to basically fast charging hubs designed for people who don't have off-street parking. The reality is, in Australia, unlike a lot of European countries and Asian countries, we actually have an incredibly high kind of urban sprawl percentage. A lot of us still have off-street parking. So, in Victoria, places like Richmond and Brunswick and all of these places with low off-street parking is actually not the norm. Whereas if you go to like Hong Kong or Singapore or, London, nobody really has a garage. And so on-street charging is a lot more important for them. But the other thing to keep in mind is that, we're about to see 800 plus kilometre range for electric vehicles. And at the same time, you're seeing already right now 15 minutes to charge to full for smaller battery packs. And so you're going to see a world where for those who need it, the act of fueling an electric vehicle is going to be very similar to fueling a petrol vehicle.
Right. Thank you. And now moving on to hydrogen refueling. Roger Dargaville, who's a professor at Monash, is wanting to know, Scott, how are you refueling those hydrogen vehicles in Canberra?
Yeah, at the moment, we've got a refueling station in the city which has been filling the vehicles up. The cars are down here are stuck in, sitting in storage at the moment. We're waiting for the hydrogen station to be finished. There's only a couple of weeks left of work to do, but unfortunately the engineers doing the work are stuck down in Victoria with all you guys. I'm lucky enough to be in the free world at the moment. But as soon as they can escape Victoria and cross the border, it'll be done. So we're probably expecting in the last quarter of this year. It should have actually been this month that the station would have been ready. We'd planned to have engineering, station validation, all the bits and pieces happening to get that done and dusted. And also the next 2 stations, so the station in Brisbane with the Queensland government, that's also being put back until Q1 next year, and the station with my colleague at Toyota, Matt, their station's been moved back a bit as well because their engineers need to come from Sheffield back. Both the Queensland and the Melbourne stations are using the one company out of Europe, so their engineers are stuck there at the moment. The hardest thing is with moving engineers around the country, whether it's stations, our station in Sydney, or there's been some amazing announcements. Actually, just in the last half an hour, I've seen some amazing stuff come out of Western Australia with the Premier announcing massive hydrogen projects and a lot of money for hydrogen and stations. So it's getting people around and crossing borders even within our own country has been a bit difficult. So I'm happy to bring engineers down from Queensland. I actually was in a session this morning with AC2 firefighters looking at the fire and rescue, and it's very simple and very easy, and it's a lot safer than a petrol car. But the guy that was going to do the course for me stuck in Queensland. I'm not going to pay for him an engineering rate for him to sit in a hotel for 14 days so he can do a half-a-day course. So we're looking at ways of working around that and having remote courses and remote learning for even things like fire and rescue for future technology vehicles.
And are these hydrogen stations going to be popping up from mostly governments? Like who's actually going to be building these refueling stations? Will it be the automotive industry?
No, it won't be the automotive industry. It'll be governments. It'll be gas companies. So think about this in the future. If you got to get transport fuels today, apart from electricity, if you get transport fuels, you're generally going to a petrol station to do it. When I'm working in Europe, I'm using to buy my hydrogen, I'm using oil company stations. So I probably use more Shell stations than any other brand in Europe. So they've got a massive investment in hydrogen. I use more gas company stations than I do oil company stations. So companies like Air Liquide in America and BAC Lindy and Air Products in the States using their stations to fill up. And then I'm also using technology company stations. So companies like Nel out of Europe and ITM Power out of Sheffield in the UK who are competing against big oil and big gas. So in the future, when it comes to selling transport fuels, it's big oil selling you this hydrogen, there's big gas selling hydrogen, and there's technology companies competing against both big oil and big gas. In some places, they might form partnerships, but where I'm seeing cities in Handberg and Frankfurt and Munich and Stuttgart, where there's more than one hydrogen being supplied by more than one sector, as in coming from gas or oil or technology, we're seeing the price come down. So it creates awesome competition. We always talk about petrol prices doing this when public holidays come up. When you've got whole new sectors competing against traditional oil or traditional gas, it's only going to benefit the customers, which is amazing. We're starting to see that now in Europe.
All right, thank you. I'll move on to another audience question by Wendy's got a question there about RSCV and their help in the transition towards electric vehicles. So if we could unmute Wendy again, that'd be good. Thank you, Linus.
Yeah, I actually used to work for the RACV, interestingly enough. And I noticed one of you used to work for the NRMA. Is that right?
Yeah, that'll be me.
So I'm just wondering in terms of because there's a lot of as Alex has already mentioned, myths out there in terms of this phobia about going to EVs. So I'm just wondering what the roles of the motoring organisations have, both in educating the public and also lobbying back to government for help with doing this whole endeavour.
Yeah, it's quite a big one. It's something that, I've been with Hyundai 10 years now, but I spent 10 years with NRMA crash testing cars and judging for Australia's Best Car Awards and writing about new cars. And I kind of got the bug to get onto the whole eco thing whilst crash testing in Korea and seeing hydrogen cars and EVs back in the R&D facilities back in 2007 and 2008 whilst crash testing there. And you could see what was going to happen, but it was always going to be a challenge in Australia, and it's still a challenge now. It hasn't got any easier. But the biggest thing for us is getting people in the cars, getting bums on seats. As soon as people drive an EV, they don't want to look back. They just want to go forward and drive it. So the big challenge is to get more drive days happening, work better with government. We're expecting, hopefully, by the end of the year, the federal government, Angus Taylor had a chat with him last week and spoke about having the national or the federal electric vehicle strategy done and dusted and released by the end of the year. It's about a year overdue. So we're and a lot of people work on that, and we had to get pulled off and working as stats guys and economics guys looking at Corona. So there's no kicking the government there. It's just a nature of the times we live in. But we really want to get people out there to drive the vehicles and work with AGL and work with Tim and anyone we can, and work with, my colleague at Ben at Nissan. And biggest thing for me is, and it's strange coming from someone who works for a manufacturer, but I still see myself as a consumer advocate. I want competition. I want more vehicles here. I want more manufacturers here. The more competition, the more awareness is from customers, the more investment in infrastructure, and the more support from government. So the more cars we get here, the more brands, the things are going to happen a lot quicker and benefit everyone, not just the energy and car manufacturers, but also consumers.
Scott, you just want more competition because you think you're going to win. That's all.
I'm happy to put our car up against any other brand that brings their car here. We're pretty confident in what we do, so I want competition to run our car head to head with. But yeah, it does drive. We may not build a car that suits everyone's needs, and we know that people are crying out for commercial EVs, and I think it's a space where we're going to see a lot of manufacturers focus there in the future. That's where your big fleets are, especially back to base fleets. So I think there's a lot of room in this market. Just need to get some things happening. But again, we've got EVs coming next year and for the next couple of years. So we'll have plenty of product here in the coming years.
Are you allowed to talk about what your predictions are for the Australian government's commitment to electric vehicles and sort of what you think they may be interested in? I know that Angus Taylor was meant to speak at your conference this year, so
yeah,
have
I'm going to give a really political question. And it's a answer to keep my head on my shoulders. There's no comment. No, I think the government's looking to support. They know that, again, they look at what's happening with public sentiment. They know since the last election, it's changed the other manufacturers, Nissan and other guys bringing technology out. The guys at Sam at Tesla as well. We're all working very hard. We're all working with government and putting a lot of time and effort in with them to help them understand the benefits. For my biggest thing and being down here in Canberra right now is helping that, or trying to get as many of our EVs and our competitors' EVs with the guys, the bureaucrats here in Canberra that are writing up the strategies for the government. The last thing was someone writing up a strategy that hasn't driven an EV. So we've been working hard over the last year to try and get product down here, to get it driven by a lot of the people that will be writing up the strategy for the government. Again, it's almost like a political get the bums on seats and create some believers.
Yeah. Now, Kristian, AGL does have their EV plan, which discounts electric vehicle owners. Have you seen a strong willingness for customers to get into the EV market, or is it still quite a little bit of is it still a bit of a touchy subject? Are people still off-put by the clean, green, and they're not fuel guzzling?
There is a variety of issues, I suppose, but also, so what's pretty clear, the market research tells us there is a strong latent interest in electric vehicles. So most people have accepted that electric vehicles are the future, and it's not so much a matter of if, but when. Tesla's done a fantastic job of effectively creating very appealing product. Good product goes a long way. I think we've all seen that with Apple, for instance, and Tesla have done a great job of moving the conversation over the time I've been working away from mobility scooters and golf carts towards something that's a lot more appealing. And you see a lot of other brands now doing a lot of good work there. So people are more broadly interested in understanding what's available, whether they might make sense for them. The presence of public charge infrastructure does certainly help sway people's views on electric vehicles. But I think increasingly the vehicles are coming out with battery sizes and ranges that are long enough to solve pretty much 90% of most people's problems. So it's a journey, but certainly we see strong parallels to the solar experience. We've seen in that market people go from perceiving solar and solar technology in the purchase decision as a wholly green type solution to one where it just made sense financially. And what we see is that there'll be a challenge because the heuristics that people form, they lag the reality. So electric vehicles will make sense for a lot of people a long way before they realise it. And the heavy lifting to educate people around the availability, the specifications of the vehicles and the common sense arguments in favour of them, that's something that we've certainly got in front of us. And we've started working on that.
Okay, brilliant. Sorry, Scott, do you say something?
It's probably for us as a manufacturer, we need to get more airtime on television. We every second ad on television is an ad from a car manufacturer. But end of the day, especially when times are very tough now in Corona, where the market's right down, Corona has really impacted car sales heavily. You're seeing all the ads of the traditional petrol and diesel cars. For myself, in the future, I'd love to see a lot more ads talking about the technology and the benefits, and the environmental benefits, the health benefits, the everyday usage benefits. So I work for manufacturing. I've got to fight that battle internally. End of the day, to stay in business, we need to keep selling a lot of what we do now to pay for what's coming in the future. And that's the nature of what the automotive industry is. We're not going to change overnight.
Yeah, right. Now there's a question here by John Short that's got to do with AGL. So if we could unmute John Short, please.
So John Short here. I was going to ask a question around range anxiety, but I thought it was more important to look at what Tesla's doing. So there's been a number of reports that it's developing a scalable whole house energy management system. And some of the points that have been made in terms of the Tesla brand name and how sexy that brand name is relative to traditional energy companies in Australia. Do you think, Kristian, Tim and Scott, that in fact you could see a Tesla type company, or particularly Tesla itself, actually getting into full-scale energy management through the use of its vehicles, and then selling a package to people who buy the Tesla car that effectively knocks out traditional energy companies? And what's AGL doing to address that risk?
Yeah, so there's a lot to that question, John, and the simple answer would be yes. So Tesla are already active in this space. They have a quite sophisticated energy system view of the world, and they have deployed the different parts of that puzzle to varying degrees. So the extent to which the vehicles interact with a virtual power plant architecture in Tesla's case is actually quite limited right now, but that's going to change quite rapidly. But of course, they're already operating their home battery and commercial battery, the power pack type solutions, and they hang off distributed energy resource management layers, DERMS as they're called. So Tesla, they have the potential to be a quite disruptive influence on the market. They already are, it could be argued, because the 70% plus of battery sales are into homes right now are Tesla power walls. So in terms of how the energy market will respond, I think probably a Machiavellian view, keep your friends close and your enemies closer, is probably the best way to do it. So we work quite closely with Tesla product. They work closely with us. We're a reseller for them. And I think, whether they're a friend or an enemy, I'll leave that for behind the scenes type commentary, but certainly we work closely with them. That's what I would say.
Alexander, I need to dive off because I've got to jump on with a government body now. So, or government, state government. So thank you very much, everyone. Any questions sent through to Alexander, I'm happy to answer them after these sessions. But I think it's important to talk about this and also, get out all our competitors' mind, Kristian's and also Tim's competitors out and talking about what's happening, because it's amazing what's happening in Australia. It's just getting people to understand the technology and sit in it, drive it, use it, charge it, see how it can impact their lives in a positive way. Thank you very much, everyone.
All right, great. Thank you, Scott. All right. Well, I'll ask my last question for the day, and then if we've got time, we'll take any other audience questions. But most of the people here are, say, minor students, and it's a tricky time to be thinking about careers at the moment. With a lot of people graduating to a shaky economy. But what opportunities are out there in the electric vehicle market for Monash graduates? Where should they be looking for employment, and how could they stand out? I'll let Tim go ahead.
Do you want me to go first? Okay, so this is not a recruitment drive or anything like that, but certainly there are roles within JetCharge for engineering students. We actually have quite recently a Monash engineering student joined. They're doing firmware development. I'm pretty passionate about this, about the need to create IP within the Australian industry. and to basically onshore our strengths. I want to encourage basically all the students on this call to look at EVs as a whole ecosystem, not as the car themselves. There are immense challenges to come, particularly in relation to grid integration of electric vehicles. I actually think one of the areas that Australia is really going to excel in is grid integration. Certainly at JetCharge, we're looking to build the best energy management system for electric vehicle charging in the world. We want to do the best integration in the world. We want to show the world how good Australia is at integrating renewable stationary storage and EVs. And certainly we've got 9 members on the team. We've got 9 engineers now at JetCharge doing software and firmware development to basically act as cops for electrons. So our job is to allocate electrons as efficiently as possible. And that's a combination of hardware, software, and firmware. So there is a role there. We have another great organization called Tritium, which is based in Brisbane, doing some of the most advanced power electronics engineering in the world for high-powered DC charging. We have even custom bus manufacturers for the first time have had to look at electric. They need electrical engineers to go in there and help them. So yeah, there's a lot of opportunity, but you need to focus on more than just the cars. You need to look at the whole ecosystem. What about AGL, Kristian?
Yeah, certainly. Yeah, I'm quite pleased to say also that we're employing, so in my area, that is. I suppose looking across the business, though, that's not a constant. So old energy is in decline, new energy is in growth, and I suppose most people on the call would probably, having tuned in today, already voted with their feet, you could argue. But in terms of just practical advice for grads, to get your CV to stand out, you've just got to show that you can use some initiative and apply yourself to projects and tasks. Bryce has alluded to the Formula SAE competition, and certainly that and the Solar Challenge. They're both viewed very highly amongst the engineering employers. That if you've been a part of one of those sort of projects, then usually that's a great way to get to understand how to work on a project and deliver it as part of a team, and that's what you're going to be doing as a grad. And I would suggest that, while they're not the only options out there, because there are other projects you can get involved in, there's community energy projects, there's a variety, just even staying networked with the alumni through Monash, the Institute for Engineers, I think, does a lot of work as well. There's the Australian Energy Institute. What's that one called again? I can't remember now. But
Australian Institute of Energy?
Yeah, Australian, that's right. There's a few acronyms around some space, but I mean, that's a light touch way of doing it. Just stay in tune with these sort of webinars, hear about what's going on, get interested in projects, get involved in projects. And certainly to get your CV to stand out, you certainly, even just volunteering for community enterprises, we view very favourably people who use initiative. And when you're a grad and you've got no real experience, then that's the way really to make yourself stand out. Show that you're prepared to throw time into different, particularly team project type ventures that show that you can work as part of a team, and that's really important. Develop your professional network, and that's what I imagine that you're all doing anyway. Is certainly part of what Alex has been organising, and I commend everyone for taking time out to give us an audience today. So thanks.
We also, I would say, Alex, as a last point, is JetCharge. We have a history of having paid internships and basically more casual work. I started the business, I won't be afraid to say, I started the business back in 2014, 2016. I kind of ran the business with 3 casual people from University of Melbourne. They were engineering students, and they just wanted to do something. And so I actually worked with them to build the business up. And I can honestly say that I wouldn't be where I am today without the help of basically 2 Matts and a Pat from Melbourne Uni, who've all gone on to much bigger and better things. But it's just casual work. And there's still some of that around. And so, certainly at JetCharge, we have that as well. So I think, yes, it is about keeping in touch and just making sure you can sneak in some work experience where possible before applying for a graduate role.
Brilliant. All right, thank you. Back to Kristian. Actually, Glenn Drover, the secretary of the AIE, is in the chat. I don't know if he's still here. He asks if you're looking forward to Battery Day on the 22nd of September. I'm not familiar with that, but are you?
Oh, the Tesla Battery Day. Yeah, it's always it's always interesting. Huge movements to Tesla stock price if anyone has Tesla shares, but they're looking to. I mean, theoretically, Elon Musk has said that it's going to be the biggest announcement they've ever made on batteries. It'll probably be like a high mileage battery, and we'll see what happens. But yeah, I'm really looking forward to it, because generally speaking, when Tesla announce something, it's not quite ready, but it's also not conceptual, and so they're a bit further along. So it's not just the lab.
They run a very open book type development plan as well, which is quite novel and unique. Those sessions can be quite long, and they are targeted at analysts. So buckle in, perhaps put the coffee pot on, but at the same time, you'll see a lot of hype come out of it as well. So I would read a variety of sources for interpretation of what it actually really means, because certainly Tesla is clickbait, and so anything they say gets a lot of coverage. But yeah, really interesting. And sorry, Glenn, for not getting the acronym right for AIE. I knew I was going to trip myself up at some stage here. So, but yeah, certainly stay in tune. There's a young energy professionals component to the AIE, and again, we see a lot of CVs come past us, and we like to see people who are, energy geeks, I suppose, who do distinguish themselves as being a bit passionate about what they're doing. If you haven't got a lot of experience, then certainly these are the sort of things that would stand out.
Yeah. All right. Well, Glenn, that's all the questions from me then. I guess I got time for maybe one more quick question. I'll just read it out. Jeff's wanting to know, is it feasible to convert existing internal combustion engine vehicles to either electric or hydrogen?
Again, quick answer, yes. But then the question, well, why would you want to? You can buy a much more progressed and probably cheaper option in the form of a used electric vehicle, for instance, and converting one to hydrogen. Well, I don't want to live next door to someone who's doing that, but at the same time, I'm sure it's possible. You'd really want to know what you're doing, and to get the thing certified for on the roads, you will be held to fairly high standards. Don't underestimate what's involved to be able to correctly engineer something that's safe for you and other road users. So, but yeah, certainly all technically feasible, but not potentially commercially viable.
Yeah, the only place where we're seeing potentially commercially viable conversions is happening in classic vehicles and enthusiast vehicles. So they generally tend to be smaller operations by people who specialize in really high-end classics conversions. And like, these are really ridiculously expensive vehicles. They're not aimed at early adopters who are looking to get a cheap EV. They're looking actually at people who want something special. They're the only ones where we're starting to see like some commercial viability. But I agree with Kristian. If you're just converting something because you want a cheap EV, just wait a year or two. There's plenty of like very inexpensive secondhand EVs coming onto the market.
All right. Well, thank you very much. We'll leave it there today. Thank you very much to Kristian, Tim, and Scott for coming and talking to us today. It's great to hear about what's happening in the EV world, straight from the horse's mouth, I guess. I would like to also thank you to Linus, who was moderating the chat today, and was useful for unmuting the correct people. I will also make a little advertisement for our next webinar, which might interest quite a few people here. If I can make this full screen. This is in 2 weeks' time. We've got one about future energy technologies. So we've actually got the Director of Energy at Tesla Australia, Mark Twiddell. Neil Kavanagh is the Chief Scientist at Woodside, and Paul Webley, who's the new Director of the Woodside Monash Energy Partnership. So I think Neil and Paul will be talking quite a lot about hydrogen, but more from the whole economic point of view, not rather than electric vehicles. And then Mark will be talking more about batteries and solar roofs, solar Tesla Powerwall. So I think that'll be a really excellent webinar. It's in 2 weeks' time. So we're taking a one week break. There's also a short survey at the end of this. It would help us out a lot if you guys could fill it out, just telling us some of the feedback and what we can improve on for our last 2 webinars. But I'll leave it there and just say thank you again to Kristian and Tim, and I bid everyone a good day and stay safe.
Yeah, thanks, Alex. Thanks, everyone.
See you later.
Thank you. Bye.